So in part two, we talked about how the North Star could be used to determine latitude. Specifically, if we could measure the angle of the North Star above the horizon, then we could use that to determine our latitude. But it turns out that star sightings were effectively only useful for latitude and not for longitude. Now, strictly speaking, there was a technique that had been developed to determine longitude from star sightings, but you had to effectively be on the ground and you had to observe over long periods of time. It wasn't practical for use on ships at sea. So how are they going to determine longitude? Well, for a very long time they didn't. And for many, many centuries, long after the discovery of the technique of how to measure the North Star in order to determine latitude, long after that, folks were traveling the oceans without really knowing how far they were east or west. So, what was the key? Well, turns out that it all boils down to the rotation of the Earth. So we know the Earth revolves once per day, so that's 360 degrees in 24 hours. You divide 360 by 24, that's 15. So the Earth rotates at 15 degrees per hour. So the idea is you set your clock to whatever the time is at your home port. How do you do that? Well, you wait for the sun to come overhead. You know it's noon. You set your clock to noon. Fine. Then you go ahead out on your voyage. And at some point you say, well, I want to know what my longitude is. And so you wait for the sun to pass overhead. You know it's noon at your location. Then you look to see at your clock what time it was or what time it is back at home at the same time. You say, well, it's noon where I am now, but the clock says it's 2 p.m. back at home. So there's a 2-hour time difference between where you are and where home is. Well, 2 times 15 is 30, so that means you're 30 degrees longitude difference from the home port. And in this particular case, you're actually 30 degrees west of your home port. Well, what's the catch? Well, the catch is that a few hundred years ago, designing an accurate clock for use on ships at sea was thought to be impossible. And this gentleman, John Harrison, made it effectively his life's work to solve this problem. What we see here is the first generation clock that he produced, H1, in 1735. And it worked pretty good, but there were some issues. It didn't work perfectly. And so he kept at it. And 3 more generations of clocks, and 24 years later, he ends up with H4. And it was effectively perfect for the purpose that it was intended for. Now you look at it and you say, well, it's just a pocket watch. Yes, it's a pocket watch, but it's not just a pocket watch. It was a pocket watch that was so accurate that it allowed the mariner to determine the longitude when they were at sea. And this solved the longitude problem, and navies throughout the world adopted chronometers for their use. Now, I've skipped over a lot of the interesting, juicy details of Harrison's quest. It turns out that the solution of the longitude problem was so important. So many ships had been lost at sea because they didn't know their longitude that the British Parliament set up something called the Longitude Prize. And back in its day, it was the X Prize of its day, the modern-day equivalent of millions of dollars at stake for the one that could solve the problem. Harrison did it after many decades and all sorts of politics and interesting issues of intrigue and various things that went on to try to conspire against Harrison. It was sufficiently fascinating that somebody wrote a book on it called Longitude, and that book was made into a movie. And it's an excellent book, it's an excellent movie, and I definitely urge you to check them out. So if we have the chronometer, we have the cross-staff or astrolabe, whatnot, we could determine longitude and latitude by observing the sun and the stars. Works great as long as the weather cooperates. And in fact, for the North Star, it also has to be nighttime. So we've got this issue. I mean, you can only see the sun once a day, or it's only going to be noon once a day. You can only see the North Star at night. You can only see the sun or the stars if the weather is cooperating. So that was always a problem. And then it's like, well, okay, so the sun goes overhead, it's noon, I can figure out, with the clock business, I can figure out what my longitude is. At nighttime, I've got the North Star, I can figure out what latitude is. Okay, well, it gives me a position, but, then what? What do I do the rest of the time? And how do I know which way to go? Well, so we need to still establish a reference direction, even though we've established our position. And this was understood even by the Chinese a couple thousand years ago, that there was a need to establish a reference direction. And so this ingenious device consisted of this figure which was pointing in a direction of interest, and it would stay pointing in the direction of interest even though the wagon would turn. So there was a system of differential gears here that would allow the figure to stay pointed in the same direction even though the wagon was turning. And so again, the Chinese had figured out long ago that there was a need to establish a reference direction. Now, for the most part, of course, the primary way that direction was established was through the use of a magnetic compass. We've been doing that for hundreds and hundreds and hundreds of years. And of course, that works quite well, regardless of the weather or whether it's nighttime or daytime. And so the idea was that you would use your star sightings, sun sightings in order to establish position, plot it out on a map, figure out which direction you needed to travel to get where you're going, and you'd use your magnetic compass in order to maintain your direction throughout the journey. So that was effectively navigation. Star sightings, sun sightings, magnetic compass. That's how navigation was done up until the modern age. What do we have now? Well, we have radio systems both on the ground and up in satellites. We have systems that are high-tech versions of dead reckoning, and I hope to be able to bring you some more tutorials on some of these technologies in the future. I thank you for joining me. For now, this has been Mike Braasch. Good day.